Build here. Let's see, it is October 16th. It's Wednesday. I know you folks don't have class, but I'm busy preparing class right here. And I wanted to come over here to the syllabus, which I hope is in front of you at the moment, and come down here. And I want you to note that you do have a program due, it looks like it's 2 weeks from today. You have a program that is due today. I've already started grading it. So I wanted to talk about a couple of things today. I wanted to talk about the upcoming program, and I also wanted to talk about some things I noted as I'm grading your program today. I've graded most of them. So first of all, let's take a look at your next assignment. So I'm going to come over here to assignments, and I'm going to scroll down here to programming assignment 2. And there is something that I have changed here just a little bit. Before, it used to give you a link to a Microsoft Word document that you would download. And sometimes I find Canvas is a little bit weird about opening up these documents and downloading them. So I actually took the document and copied it into here. So this is exactly the same as what is in this document contained down here. So let's take a look at this very closely. Programming assignment number 2, and again, it says you will need to demo this to me in lab. You know something? That is not true. So I'm going to come in here and get rid of that. So let me do that. You get to see Canvas in action. And I'm going to come down here and save this. And let's go back and look at it. I say you may now use assembler language. If you don't know what that is fine. And if you do know what it is, that is also fine. You can hear my cat meowing in the background. If you want to read ahead and look in chapter 7, you can do that. But anyway, here's what the assignment is. There are going to be 10 numbers stored contiguously in the computer at location 7,000. Again, you can think of this as an array, and that's exactly what I would like you to do. And then I say write a complete LC3 program starting at location 3,000 that will find the location of the smallest number in the array and swap it with the first number in the array. So I give you an example right over here, and I say, look, here is an array starting at memory location 7,000, right there. At location 7,000, I have the number 123F. 7001, I have 6534. And you can see I have a total of 10 numbers. It goes all the way down to 7009. That's the memory location right there. And the value that is stored in there is 54EF. What your program needs to do is it needs to go through this entire array, and it needs to find the address of the smallest number that it finds in here. Now, when I come in here, it seems to me that the smallest number I find in here is right over here at location 7007. The smallest number in there is 0042. I think you'll see that in this particular example, all of the numbers are positive numbers, and in this case over here, the smallest one is 0042. What I want to do is I want to swap 0042 with memory location, whatever's in memory location 7,000. So you can see that the 123F came down to 7,007. There it is right there. And the 0042 got swapped down here to memory location 7,000. So I just found the smallest element and I swapped it with the first element. If you prefer, we can even think about what this code might look like. Give me a moment here because my desktop is loaded with stuff. If we were doing this, for example, in Java, and again, you have to give me a moment here. I'm going to come over here and I'm going to say, I think this is up on your screen. And if I would have an array that look like the following. Here's my array. I'll call it AR 1, 2, 3, 4, 5, 6, 7, 8, 9, and it looked like this. If I were writing this in Java, I might come down here and I might say something like the following. I might say int low equals 0, and I might have int j, and I might come over here and say for j equals 1, well, j is less than or equal to 9, j plus plus, and then inside of the loop, okay, so basically I've assigned low gets this value 0. And I might come in here and I might say something like the following. If AR of j is less than AR of low, what I would do is I would let low equal j. And that's the only thing in the loop. So you can imagine that I have something like this. 29, 83, 56, 42, 103, 9, 256, 387, 4, 592. Now you can see that as I come over here, low is initially given the value 0. And now I come over here and I say, well, if AR of j, I'm now over here at 1. If this is less than AR of low, well, it isn't. 83 is not less than 29. 56 isn't less than 29. 42 isn't less than 29. But watch what happens when I get down here at 3, or at 5. Now, it turns out that AR of j is less than AR of low. So now what I'm going to do is I'm going to let low equal 5. So I come over here, and low is no longer here, but it's now over here. But I'm not done, okay? Now, this is not less than 9. This is not less than 9. This is less than 9. So I'm going to reassign low down to here. So now I come over here and I say low is now 8. I get rid of this. Okay, and finally I get down to 9, and it's not less than that, so I'm all done here. But now there's just one more thing I need to do. I just need to say if low doesn't equal 0, then what I need to do in here is come in here and say AR of 0 whoops, I've made a mistake here. I'm going to get rid of this. But I think you can see what good needs to happen here. I just need to do a swap. So I'm going to come over here and I'm going to say let temp equal AR of 0. AR of 0 equals AR of low. And AR of low gets temp. I'm going to just say over here swap. So this would be the code in Java. You just need to do this in the LC3. Okay, with that out of the way, I want to talk about some issues that I have seen in the submissions today. And what I want to do is I want to come over here to the LC3. and I want to talk about life as a teacher. Now, I think I gave this demonstration in class. In fact, I know I did. And I want to talk about it again. So what I've done is I've actually copied a couple of your programs into a text editor. Um, so I want you to imagine that here is a submission that I just received. I think you can see this all over here. Now, what I do when I'm grading this is I come over here and I open up the raw window, and then I come over here to this program, and what I do is I copy it, and I don't know why. Let me just... Here is the program, and I'm going to come over here, and for some reason this is no longer working. I don't get it. I'm using a funny notepad here. There we go. So I'm going to come over here and I'm going to say edit, copy, and I'm going to come over here into the box and I'm going to say edit, paste. So there's the program there. And now I'm going to come over here and I'm going to hit the process button. And it doesn't like it. And the reason why it doesn't like it is because this person chose to submit a program with these X's in it. And we never did that in class. So what I have to do to get this program to work is I have to come along and now edit every line in this program before the program will work. For example, if I try to process it now it's telling me the error's at line 8, which is of course right here. And again, I continue like that. And if I process it again, you can see it's now gone to 11. So submitting programs with an X in it doesn't work. I'm going to come over here and I'm going to say cancel. And I'm going to go to my next example. I'm going to come over here, raw. Let me get rid of this. And I go to my next example. So here is somebody that chose to submit their solution with addresses in it. And again, I'm going to come over here and I'm going to do an edit copy. And I'm going to come over here and I'm going to do an edit paste. And I think you can see I hit a process. And oh my goodness, well, that one worked. I'm very surprised about that one. Load into simulator. And that appears to work. Okay, I'm actually surprised. I'm going to come over here and clear out the LC3 because I want to show you one more that I received, and I actually got a lot of interesting looking ones. If I come over here and look at, I decided not to copy it. Here's what an answer should look like, I think right here. You notice here, by the way, that this answer here, the very first line has to be a line number with a memory location that it's going to load into memory. I had people give me solutions that look like this. And the problem is it's going to load this program to memory location EC13, and then this instruction will be missing because if I try to load this in, if I load this in, it's going to start at EC13, it will load in the following instruction, the 60C0. The point that I'm trying to make is that when you put together a file to submit to Canvas, you should at least check the file and make sure that what's in it can be directly copied into the LC3 and loaded and executed. If it can't do it, then there's something wrong with the way that you have formatted your program. So please try and do that next time. I did have to spend a lot of time sort of forcing people's programs to work. Okay, thank you.